In this video, we're going to learn about effusion and diffusion. So you may recall that temperature is the average kinetic energy in a sample of many molecules. And you may also recall that kinetic energy is equal to 1/2 mv squared, m being the mass and v being the velocity of whatever we're considering. So at the same temperature, two gases, gas A and gas B, will have, on average, the same kinetic energy. So what we can say is that 1/2 mv squared for gas A, that's why we have m sub A, v sub A, that is going to be equal to 1/2 mass of B times the velocity of B squared. We're just basically saying that Ke for A is equal to the Ke for B, again, if gas A and B are at the same temperature. And so based on this information, we can conclude that xenon will actually move more slowly than helium at the same temperature. How do we know this? Well, I know that helium is light, so I can say a low mass, and that xenon, well, that's heavy, it has high mass. And in order for this equation to hold, because they're at the same temperature, if, say, xenon is the one on the left, it's got a high mass, and helium on the right has a low mass, helium's going to have a bigger velocity to compensate. So xenon will move more slowly than helium at the same temperature. So it's interesting because, the temperature, if they're at the same temperature, they have the same kinetic energy on average. That does not mean that they're moving at the same speed. It means that something heavier is moving more slowly and something lighter is moving more quickly. Something to compare, by the way, if we have, say, a fly and it's moving along and it hits you, it could be moving super fast, and it won't really exert a lot of energy on you because it's so light. But a car that's barely moving, if it hits you, you will move. It's moving slowly, but it's heavy. These two factors are relevant here: the speed of something, the velocity, and the mass. So let's play around with this, with what we know. If we're talking about two gases moving at roughly the same at the same temperature, therefore having the same kinetic energy. So if we know that they're at the same temperature, we know that the kinetic energy of gas A and the kinetic energy of gas B are the same. We also know 1/2 mv squared for one of them is equal to 1/2 mv squared for the other. We can rearrange these. If I get rid of the 1/2s and divide by the velocities on both sides, I can get to here. And if I take the square root of both sides, I can get to here. And what this eventually brings us to is that the rate of effusion of one gas divided by the rate of effusion of another gas is equal to the square root of the ratio of their masses. What does all this mean? So if we go to the question of, at any given temperature, how much faster will hydrogen effuse than oxygen? We can answer that question using this formula right here. But first, what are we even talking about here? Let's say that I have a box and we have some hydrogen molecules and some oxygen, which I'm going to show in red. So if I poke a hole in this box right here, then just through random motion, those particles will leave. But remember, they're at the same temperature and they have different masses. They won't be moving at the same velocity. And if they're moving around randomly, well, whatever is faster is more likely to leave at any given moment. They're not all heading towards the exit, but as they're moving around randomly, the faster they are moving randomly, the more likely they are to escape. So again, we're trying to figure out how much faster the hydrogens will leave than the oxygens. And for this, we have to say that the rate of effusion for, let's say, hydrogen over the rate of effusion for oxygen. I'm just copying the previous equation, this one right here, without writing all of those words, but the rate of effusion over the rate of effusion is equal to the square root of, this is going to be the molar mass of oxygen. So this is going to be the mass of O2 divided by the square root of the molar mass of H2. Now, oxygen, as O is 16.00 grams per mole, so O2 would be 32.00 grams per mole. And in the bottom, in the denominator, we're going to have the square root of 1.01 times 2 is 2.02 grams per mole. That's the molar mass of hydrogen. And the units are actually going to cancel. And what we're going to find is that the ratio is 3.98. So what we're saying here is that hydrogen effuses 3.98 times as fast as oxygen at the same temperature. So we're going to have the hydrogen escaping at a rate 3.98 times the rate of oxygen escaping. So I hope this video has been helpful. Let me know if you have any questions in the comments section below. Thank you.